quiz. Quiz number 6 was about radius convergence and interval of convergence. Okay, so step 1, we need to find the radius of convergence, and for that we do the ratio test. Okay, as always, we take the expression minus 1 to the power n, x minus 4 to the power n, n squared to n. Well, before I go on, let's already make note of the fact that the center is 4. Okay, so now I have to put the same quantity on top, but replacing n by n plus 1. So I do that here. I replace the n by n plus 1 here. The n squared, because now n plus 1 squared, be careful, the whole thing is squared, so that's why I need parentheses, and the 2 to the power n becomes 2 to the power 2n plus 1. Now the absolute values, we talked about this, means that we don't really have to care about these guys, and also about all the numbers that are positive. So if I simplify this now, let's see what we have on top. This guy is on top, so but we have the right absolute values here. And then on the bottom, we will have this n plus 1 squared and this 2n plus 1. And then it flips kind of over, right? So you have this guy now here, and these two guys will go on top. N squared and 2 to the power n. And so powers can cancel here. Always the highest power. We look always where the highest power is. Here it's on top. So hold this is we have a power 1 left. Let me write like that. And then here the power is in the bottom, so we have a power 1 left also there. Okay, so what we have? Okay, but let's put already the things that do not depend on n outside, that we don't get confused by them. X minus 4 and a 2. And then we have n squared over n plus 1 square. So this is x minus 4 over 2. Now we have talked about many ways of doing this limit. The quickest way is to actually write it as a single power and take the limit inside, and then we very quickly see that this limit, if it divides top and bottom by the highest power, it has to be the same power when you calculate the limit. It has to be the same power, right? Because otherwise you change the fraction. Some of you are doing this, confusing this with the limit comparison test where we create something. Okay, so here this is x minus 4 over 2, and then we have the limit here for a 1 there, 1 plus 1 over n squared. Now this, of course, this last reciprocal here, that goes to 0, so the whole thing here is just 1. Okay, so the conclusion is we get the ratio of we get x minus 4 over 2. Now, we know that this is a condition, and the condition is that this has to be less than 1. We solve for x minus 4 to find the actual radius of convergence. So we have x minus 4 is less than 2, and so this is the radius of convergence. Okay, don't forget that you have to solve for x minus 4. Good. So what does that mean? That means that the interval of convergence, if the center was 4, and we can go 2 in either direction. That would bring me to 6 and 2. So this is the radius of convergence. Let me write it here. Radius of convergence. Now, as far as the interval of convergence is concerned, this means we have to think about what happens at 2 and 6. So I repeat, we have already convergence here, but we don't know what happens at 2 and 6. Okay, so we have to, the step 2 is the endpoints of this interval. So x is 2. Well, what we do, we plug in 2 inside this function. So we put in 2 here, x is 2. Okay, so we get summation what am I doing? Minus 1 to the power n. Then if I do 2 minus 4, that is negative 2 to the power n. In the bottom we had an n squared and a 2 to the power n. I always told you to take out the negative signs in the power. So we have this, and then we have an n squared and then a 2 to the n. And then, of course, clearly these 2 to the n's cancel. What about these negatives here? Well, they're twice the same thing. It's both are negative 1 or both are positive 1, so the whole thing is just 1, because it's actually minus 1 to the power 2n, which is an even power, which is always positive. So we get summation 1 over n squared. Now this is a p-series, where p is 2, and therefore this is convergent. Okay. Step, that was endpoint x equals 2, the other endpoint is x equals 6. So we do the same thing, we plug in here, now we're putting x equals 6 in here, we get summation minus 1 to the n, 6 minus 4 is now 2 to the power n, n squared 2 to the power n, they cancel again, and we get this series. Now, we can do the alternating series test. So let me do that. That's perhaps the first thing you think of, because it's an alternating series. So that means I have to take this limit. It's 1 over infinity, which is 0. So again, well, I should not write check mark. It's convergent as well. Alternatively, you can say, well, look, this series is a p-series, and that's the absolute value of this series. So this means that actually the series that are this last series is actually absolutely convergent, and therefore in particular convergent. Okay, that's another way you can do it. Fine, that's it. And so, meaning if you want to denote this, we would make this 2 full points, or you would write it, the solution is 2, 6 included, where you use square brackets.